All right, so my name is Erik, and with me I have Alex and Nezdoli, and we're here to talk about how we migrated HTTP traffic from our old system to our new Envoy-based one. Now, someone told me that this is the worst way to introduce a talk, that you should say something funny or tell a joke. I'm not a funny person, so you will not hear a joke from me. So we go with that thing I just said instead. All right? Great. So here's roughly the agenda for the talk. I will try to set the context and describe our old system for you, what we're migrating from. Nezdoli will talk about our new system. And then Alex will talk about the migration itself, and finally we'll share some learnings along the way. All right, so just quickly about Spotify. Most of you probably know what Spotify is, but I will go through it quickly anyway. So it's the world's largest music streaming service. We have 248 million monthly active users. It's a global product, so we're on, I think, 79 markets right now. We're on hundreds of different platforms, so phones and cars and speakers and so on. Our service infra runs in GCP. So we're in 3 regions, US, Central, Europe, and Asia East. At peak, we serve about 8 million RPS, and the backend we have is a microservice backend. So fairly standard stuff. This is kind of what it would look like. You've probably seen dozens of these pictures. So on the left, you have the various Spotify clients, and on the right, you have the various Spotify backend services. One thing to note is that we serve content from CDN, so like the actual music audio files and thumbnail pictures of an album art and so on comes from CDN. And this black line here is the perimeter, the border between the internet and our backend. And if we zoom in on that a bit, this is what it used to look like in the way, like really old times, like 2010 or 11 or so. So we have this client sending RPC and establishing stateful connections over mystery protocols to our legacy stateful service. I divided the traffic up here in RPC and stateful sessions. And then to the backends, the perimeter would speak Hermes, which is our homegrown HTTP 1.1 version, which we're very much working to migrate away from. And the sessions are used for things like playlist updates. So you follow a playlist and it gets an update, and we can tell the connected clients about this happening. And remote control is also a big use case. Right now, or like rather half a year ago, the perimeter looked like this. So we're slowly but surely moving away from the legacy stuff on the Ingress side to more standard protocols like WebSockets and HTTP. And then we have a gateway that translates between Hermes and HTTP, so that we can decouple the backend migration from the client migration. And lastly, we have web traffic. So mostly websites, the www.spotify.com, web player, and about 150 different websites that we have. And a couple of REST APIs as well. And this talk is mainly focused on this part, which we now have migrated away. So if you look at the web load balancer for a bit, this is kind of what it looked like, the old system. So the 2 main components in this one is Nginx and HA proxy. And basically a browser would make a DNS lookup of www.spotify.com, for example, get a response that routes it to the closest TCP load balancer, regional TCP load balancer. Remember, we're in 3 regions, so if you're in Europe, you will go to the Europe one. The browser would connect to the Nginx, which would terminate TLS, and HA proxy would then load balance the traffic over over the upstream servers, right? The system is configured with Puppet, so the user interface the interface to the Spotify teams to use this is to write YAML files and Ruby templates. And we have about 25 different features exposed. So you can do redirects and configure custom health checks and set timeouts and so on. Another thing to note is that we use Puppet for doing service discovery. So basically, if you spawn up more instances for your backend cluster, they would be registered in our service registry, and then on each Puppet run, Puppet would populate the HA proxy configuration with new hosts. So this system has served us well for 7 years or so, but it's not it's not really good enough anymore. Like it's hard to extend. It's not very flexible. Like Puppet and Ruby and all on, but it's become quite of a mess. As I mentioned, the service discovery being tied to Puppet has the drawback that it's quite slow. I think a Puppet run normally takes between 7 and 10 minutes on one of these hosts, which doesn't work very well with ephemeral services like Kubernetes is not playing along well with this, for example, and it's unintuitive to use. So like these features that I mentioned, they've been added haphazardly over the year, kind of. So there are some that don't make any sense anymore, and others that have been added twice with different names. And most importantly, maybe that anything we would do with this system would only benefit the actual, like the web traffic, and not the rest of the ingress traffic. So what we want to do instead, we have this vision of the unified perimeter where we want to build one system in front of all these different types of ingress traffic that we have, and have that thing do all the perimeter things. So I put up a nice list here of things that we imagine the perimeter could do. I'll let you read that. So doing stuff like authorization, adding support for new protocols. We've been looking at Quick, and there's a strong push for IPv6 right now as well. Security hardening and creating audit trails, and all of these things we want to implement once. And just to mention, like we have, for example, I think we're up to 5 different authorization systems within Spotify, and at least 3 implementations of global rate limiting. So yeah, so these are things that we want to implement once in our new perimeter and support it there. And yeah, now Nezdolii will describe how we built our new system and which proxy software we decided to use. And you will never guess which one it was.
Hello. So while considering multiple load balancing and proxy technologies for next generation perimeter, we decided to go with Envoy for multiple reasons. First, and the main one, as Spotify is moving up the stack and adopting CNCF cloud tech,
check.
Like Kubernetes, Service Mesh, and GKE, Envoy turns out to be a natural fit for our environment. And by moving up the stack here, we mean that we either adopt the existing ones or develop our own tools to hide the complexity and help developers iterate faster by focusing on what's right for them, mainly on the product features. Next, XDS, the shining feature of Envoy, which helps us to manage our proxy instances at Spotify scale. And as an open source project, Envoy gives us power to move faster and to make impact by contributing. And last but not least, Envoy evolves quickly as community is quite responsive to customer needs. And here you could see the overview of our new perimeter. We call it Edge. And we currently allow our users to expose HTTP, HTTPS, and gRPC services. We leverage GFE, Google frontend, as a global L7 load balancer. And with Google, we can just expose one IP and let Google decide which data center and which point of presence to connect and to route traffic to. Sorry. And we currently run 100 standard 8-core GCP instances for our proxies with some over-provisioning next to XAUF and stats collector. And with this setup, we serve 1% of all ingress traffic. And for us, all the requests need to be authorized, which adds some extra latency. And nowadays, we use XAUF not only for authorization, but also for GOAP header declaration, which is not the purpose of authorization API. And there are multiple reasons that drove that decision. At the time when the service was developed, our engineers wanted to move faster. They didn't want to spend time on setting up CI/CD pipelines for Envoy extensions, and also they were just simply more familiar with Java. And currently, New Edge supports most common features like exposing your service, doing SSL termination, authorization, GOIP, redirects, and house checking. And we also run a control plane in a separate cluster to configure our proxy instances dynamically. And the reason why we decided with our own control plane is at the time when we started the project, there was no existing control plane that would satisfy our needs. And also we wanted to tailor exposure API to Spotify requirements. And with a new Edge setup, we introduced multiple risks. As a service exposure is now centralized in one system, bad deploys could take down everything. There is also a risk of overexhausting the resources by bad citizen, as resources are now shared. And for potential outages with cloud load balancing infrastructure, we came up with what we call Edge Direct setup. Is basically we are exposing our proxy instances directly to the public internet with external DNS and leverage load balancing to DNS. And now my colleague Alex will tell you more about the migration process.
Thank you. Hello, everyone. So I am going to be talking about the steps for the migration, like what we did in what order. We're going to start with going over the goals we set for the migration before we even started. So the first goal we had was that we wanted it to be transparent for both up and downstreams. With transparent, we mean that there should be like no visible change once we switch over to the new system. This is especially important for us for the upstreams because there's a lot of talk within Spotify about migration fatigue, and we're constantly moving to new things. So we wanted to take the burden away from anyone else and just have it work. We wanted to target zero downtime so that our end users would not see any deterioration in the use of our different websites and apps. We wanted to make sure that the migration was gradual so that we moved a bit of traffic at once so that if we ran into any issues, we could, it would be only localized to this one site or part of traffic that we moved, so not everyone would have an issue. And it was very important for us to, during this migration, have some sort of very easy and quick safety switch, like a red button you would just hit, and all traffic would move back to the old system, which we know worked. This red button was only metaphorical. It was not actually real, which is a shame. We could have brought it here, hit it, made a live demo, introduced some excitement into this presentation. So the first step we took after setting out the goals was we wanted to put some traffic on our new system and learn about how it would perform and operate. So we wanted to start quite small. We needed to find something that wouldn't have a big impact, or big bad impact on anything if something went wrong. So out of all of these different perimeter systems we have a separate deployment of the HTTP to our custom protocol Hermes, the gateway. This a separate deployment is only used for experiments like hack projects and stuff, so we thought we can move this because we promise much lower availability and SLO for it, and it shouldn't have anything related to production on it. And we moved this using simple DNS change, no like very strong, easy way to switch back, but we thought it was good enough for this first test. And it worked quite well, we learned a lot. Next, we needed something more substantial, we thought, so that we could prove that we can actually move the websites. So we decided to move the Spotify web player, which is available on OpenSpotify.com. So it will be, today it's served by Envoy. We decided to choose this specific service because it serves a significant amount of traffic. And the team that operates the service, they are based in Stockholm, same office as us, so we could collaborate with them. Here is where we started devising the actual gradual rollout strategy. We considered a few different options like redirects and other stuff, but most of it was, it didn't fill all the business needs for the different websites. So in the end, we decided to go by using the Cloud L7 load balancer that Google has. We migrated the old legacy system from the regional TCP load balancers to sit behind the L7 load balancer. And by doing this, we could use the APIs available to move traffic from the old system to the new system. And this also gave us the fast safety switch we wanted, because when you make this API call, it takes a few minutes and traffic will go back to the old system. And initially, we were only running this web player during office hours on the Envoy solution. The reasoning for this was that we were not quite yet sure how we wanted to set up our monitoring and alerting, like which signals to alert on and what thresholds to use. So we wanted to gain some more insights into that before we ran it 24/7. So once we had moved the web player and we were happy with the state of it, there was of course about over 100 more services to move. So we had to devise a strategy for doing that. So as my colleague Erik mentioned earlier, there were about 25 features that developers could configure for their different services they exposed on the old system. So we had to make an inventory of these and realize how we would implement them in Envoy. While doing this inventory, we were also very conscious about, can we get rid of some of these features? Do we really need all of them? Can we do them in a simpler way? So we made a lot of effort into reducing the configuration surface. And we also finalized the monitoring and alerting so that we had more confidence that we would catch errors early and in an automatic way when we moved the rest of the traffic. So what we ended up doing was we did indeed get rid of a lot of the different configuration parameters. Like was mentioned, some of them was just a no-op, they didn't do anything anymore, or they were duplicates. The majority of services in the old system, they used a subset of these different configuration parameters, which was a bit simpler and more straightforward. So we could migrate most stuff with a script. So about 75% of the services we migrated with a simple script. The remaining 25% all were a bit snowflakey and used different features. So we thought it was simpler to simply port them manually and have peer review than add more edge cases to the script. One consequence of how we decided to do the gradual rollout that we ran into here was that we did not quite have the granularity we wanted when choosing which traffic to move. So it ended up being a bit of an either-or rollout. You either moved some of all traffic or all of all traffic to the new system instead of a little bit. To sort of showcase this is sort of how the setup looked like. You had the Google load balancer, and behind it you had your two different systems, the old one and the new one, and you sort of shut off traffic to one of them, and then it would spill over to the other one. But anyway, we moved all the traffic, and what we ended up with was that we now serve the same traffic as before, but with much fewer cores. So we have a cost saving for the cloud computing part. A caveat here is that the old system is 7 years old, and we moved to the cloud, what was it, like 3 years ago? And when we moved, someone probably just over-provisioned this old system and didn't think much about it. So we still save some money, but yeah. One cool thing is that we got the project and we could announce it being GA for HTTP upstreams before the Spotify Hack Week, which all of R&D participates in, which means that we got a lot of new users on it during this week, and we got a lot of really good feedback. It seems that we're doing something correct here. People are quite happy about how it's more intuitive to configure services, which is really good. And this red button I mentioned ended up being very, very useful during the migration. Like if sort of how the procedure was that someone would come into our Slack channel, say, hey, is something wrong? And everyone would like immediately hit the button. And then we would ask, we're looking into it. And a few minutes after, did it fix itself? Yeah, it fixed itself, which was very useful. So please welcome my colleague Nezdoli back on stage as he will talk about the learnings and some of the problems that caused this hitting of the red button.
Hello again. Alongside the migration, we didn't achieve our dream of zero downtime. We actually broke our 3.5 nines monthly SLO and used up the error budget. Our team experienced multiple incidents, which were caused by human factor when manually reporting the scripts, by not foreseeing some corner cases, and also due to lack of insights into Google Cloud load balancing functionality. We also bumped into some unexpected failure modes. One example is when XAUF service was overloaded, our Envoy proxy instances were configured to return forbidden, which is a client type of error code, so that GFE didn't direct the traffic out of overloaded proxy instances. Also, we expected WebSockets to work out of the box when moving the WebSockets traffic, but we actually had to enable WebSockets manually, and it turned out that Envoy didn't fully follow ROC with the regards of content-led header, and it was quite confusing to discover during the troubleshooting. We also expected performance to improve significantly, but it was a surprise for us. It turned out to be order of magnitude lower to compare to publicly available benchmarks. So we did run a production load test on 10 8-core GCP instances for Envoy machines with a vanilla setup. And after that, and we put like a production load of 600 QPS. And after that, we saturated the cores and reached 100 CPU usage. And finally, we did the breakdown, and it turned out that Envoy was using 75%, and the rest was used by XAUF service. So alongside the migration, we also encountered some Envoy bugs and filed patches upstream. One example is a bug with XAUF filter. So whenever user wanted to configure the route with a direct or a direct response action, the XAUF filter was just working in loop mode. It was skipped. So we fixed that. And one more example is when our team was working with gRPC house check-in for the upstreams, and as our infrastructure is enforcing gRPC deadlines everywhere, we found out that Envoy wasn't propagating that, so we fixed that as well. So far we have just migrated HTTP and HTTPS traffic, but we have lots of things planned ahead, and the main task for us is to move the rest of traffic behind edge or new perimeter, and which entails RPC and persistent connections. We would also like to run our systems on Kubernetes, as Spotify is moving towards ephemeral infrastructure to reduce the cost and maintenance load. And we would love to remove a header decoration with regards to JP header decoration from XAUF service into dedicated Envoy extension. And we were thinking about doing performance tuning, as it's not satisfactory for us, and we have already identified the potential areas of improvement. We would also like to support more authorization schemes for our customers, such as IAM, JVT, Okta, and our custom authorization schemes. And rate limiting has been a very common ask from our customers, and it hasn't been supported in the old system as well. And lastly, we were thinking about exploring adaptive concurrency for reliability. And this is it from us. Thank you. Here you could find our contacts, and in case you have any questions for us, please come and find us at KubeCon. We would like to have discussions, and we will also be happy to hear about your experiences.